Okay, so what I'd like to do is walk you through the carbon cycle lab. I always get a lot of questions about that lab each semester, so let's see if we can kind of clear that up for you. So the best way to get to this lab, I think, is I just click on this course resource newsletter right here, and it has some information for the carbon cycle lab, and I think the instructions in the course are not super excellent. So I'd like to use these detailed instructions for the different steps, and then these are the questions we'll answer at the end. So the first thing I'm going to do is download the data table. That way I can have that, as I'm working. And I'm going to move that over here. That way, we can work on it and put our data in here and all that sort of stuff. The next thing I'm going to do is open the simulation. And so here's the simulation. And I'm going to make that a little smaller. And then I'm going to also open the detailed instructions for step 1, lesson 1. So I'm going to have like all 3 of these things up at once. You may have to switch through tabs, but anyway, I like to do it this way. So basically, the first thing we're going to do is, these are the default settings. So we're going to run the simulation to 2100 with the default settings, and we'll use our data table, and we'll record the total carbon levels in each sink at 2060 and 2100. And then we'll answer some questions. Okay, so I'm just going to run this for a decade. Wait, I'm going to reset this. So first thing I need to do is I need to write, what we've got now. So atmospheric carbon is, let's see, the gaseous carbon is 391. And I'm going to put, I'm going to write it like this, just for now, and then I can, always erase that later, but I can't, get it back. So for the surface, I'm going to put 1,000 plus 0. For the deep ocean, I'll put 38,000 plus 0. Oil and gas, I'll put 500. Coal, soil, and terrestrial plants. Okay, so I'm just going to kind of leave it like that. And this is, I'm just going to leave it like that. And then I can always, edit it later, but at least I've got all the information I need. So I'm going to run a decade. This is 2020, 30, 40, 50, 2060. Okay, so for 2060, I'm going to write like this. Okay, and then I'm going to run it again to 2110. Okay. Okay, so there's step 1. And then the questions, remember, were in in here, which if you look, they're the same questions here. So I'm going to just put the questions here. That way I don't forget to answer them later. So I'm going to put this here, and I'm going to say that I'm going to write that these go to lesson 1, step 1, so I don't forget or get confused. You know, where am I supposed to be looking at these? So you can go ahead and answer them now, or you can collect all your data and answer them later. It's up to you. I'm not going to answer the questions because I want you guys to answer those, so I'm going to go to the next step. Okay, so now I want the detailed instructions for lesson 1, step 2. Okay, so this says in many scenarios the atmospheric concentration of CO2 is projected to increase beyond 700 ppm by the end of the century. However, this doesn't account for carbon released by burning fossil fuels. To find out where it really goes, we're going to run the simulation at a time, 1 decade at a time. We're going to record the total amount in the atmosphere, the number in the sky, and other carbon sinks. Okay, so we're going to look at terrestrial plants, soil, surface ocean, deep ocean. Okay, that's basically this one and this one. And then as carbon moves through the system, we note that 1 ppm of atmospheric CO2 is equivalent to 2.1 gigatons of carbon. And then as you record your data, keep in mind that this is a simulation. So we're basically going to do this, you know, one at a time. So the total carbon emissions from the smokestack is is 391. So this right here, this 391, this is the what's coming out of the smokestack. It's not immediately obvious. And then the atmosphere is the 720. So now that we know that, we can, you know, we can take that out if you want, or you can just leave it there. It's not hurting anything. Now for the atmosphere is 720. Ocean surface is 1,000 plus 0. I'm going to leave this 1,000 plus 0. I think they're basically just showing you the, you know, what you're starting with and then how much is getting added. But I'm just going to leave it. It doesn't hurt to have more data. You can always, you know, if you don't need it later, you could take it out, or you can just leave it. I like to err on the side of collecting more data than less. So now I'm going to do, this is the next one. Okay, I'm going to skip ahead to like 2050, or I'll do 2060 actually, since I already have that data. You guys aren't going to be able to skip ahead. You're going to need to, you know, do this yourself. I just don't want to, you know, do the whole simulation for you. Plus, then this video would be really, really long. And then I'll continue it up to 2100 because we already have that number too. And again, you guys will just record your data for every for every 10 years. Okay. These questions are actually for part 1 too. But I'm going to write in here that they're for that way, you know, I know what they're for. And so again, you can answer these now, or you can, you know, you can skip it. Any notes you took, you could make those there. And then there is a lesson 2, and you kind of have to scroll down a little bit to get to lesson 2. So some people, you know, don't realize it's there. I have the detailed instructions for that here. So I'm going to click on that. This is lesson 2, step 1. So it says, in a best case but very unrealistic scenario, imagine we discovered an unlimited, clean, and cheap fuel source that emitted no CO2 into the atmosphere, bringing fossil fuels use down to zero. Would the carbon cycle naturally bring atmospheric CO2 back to pre-industrial levels? So it says press the none button next to fossil fuel use to bring CO2 emissions to zero. Then run the simulation for 100 or more years to see what happens. Okay, so in 2010, I'm gonna write what we have. So atmosphere was 720, and I'll write the 391 here. The ocean surface was 1,000 plus 0. Deep ocean is still 38,000, right? Because this is our starting level. This is where we're at. Well, we're a little more than this now because we're almost 10 years past this simulation. Okay. And I'm going to make this red. That way you'll see it better. Okay, so now I'm going to run a decade. Okay. Now let's see what happens. Oh, this should be plus 10. Okay, now we'll do to 2100 or 2110, I guess. Okay, now we're not back at 280, right? Well, let's keep going. Let's see if we can get down to 280. Do you see how it kind of levels out at 347? So even if, like, tomorrow we stopped using fossil fuels, you know, we wouldn't be able to get to back down to 280. It's just not possible because we've got, you know, CO2 all the time. So so here's our data. Now technically the assignment in the course does not ask you to answer these 2 questions, but you know, to get the best out of the lesson, it would be helpful to answer them. So there's that. Now let's go back here and let's do lesson 2, step 2. Okay. Even with no further input from humans, the elevated levels of CO2 caused by a century of burning fossil fuels will continue to impact the carbon cycle, blah, blah, blah. Reducing emissions to zero is far more far from realistic. Many scientists agree a doubling of pre-industrial CO2 concentration to approximately 550 ppm is a reasonable target to shoot for in order to avoid the most serious impacts on climate change. How much of a change in fossil fuel consumption would we have to make to limit atmospheric CO2 to that level? Return to the simulation, change the annual percentage in fossil fuel usage until you can keep atmospheric CO2 below 550 ppm in 2100. So if I go up to 2100, right now I'm at 1244. So that's not what I want, right? So let's try we could do this. Let's try 1, see what happens with that. Okay, we're still too high. Let's try 0.7. Still too high. Still too high at 0.5. Let's try 0.3. Ooh, still too high. Remember, we need it to be below. So let's do 0.2. Okay, there we go. 0.2. Okay. Now, once we found appropriate level, let's leave it there. Okay, so we're going to leave this at 0.2. Okay, and now we'd say that deforestation was decreased by 50%. Okay, so so instead of 1 gigatons, half of that would be what, 0.5? Okay, so I'm going to reset this. I'm at 2010. My atmospheric carbon is 720 with 390 ppm CO2. And the deep ocean is 38,000 plus 0. Excuse me. Now I'm going to run to 2060. We're going to be at 855, 472, and then let's do it one more time. Now this wants to know how the levels in the soil change. So I'm going to actually make another column. And I'm going to call it soil, you know, since that's the thing they wanted us to look at in the first place. Oh dear. Okay. And then I'll add the 2060 and the last one, and then I'll just go back to the beginning and get that later. So we have what, 984. And then we have okay. Okay, so you can see how, this was the carbon levels in the soil, and you can also see, you can go back to part 1, and you can see your carbon levels in the soil here too, so you can kind of see how it changes. Make this even smaller. Okay, and then I'm going to put these questions here. Okay. Now what I'm going to do for you guys, that's not right, is I'm going to take this one that I've kind of worked on and I put the questions in. I'm going to take out my data, but I'll put the links to the instructions in here, and that way you guys will have those links straight there, and you'll be able to kind of just download this data table from the course.